Hi, I'm Gary Millette, and today I'm going to talk about switches and relays. This is topic 13A for ELE 110 Electronics for Technicians 1. This is the fall of 2022. So let's get started. So switches are a very common component in electronic systems. Mechanical switches are used in a myriad of applications, and some of the more common types of switches are called toggle, slide, push button, limit, micro switch, dip or DIP, rotary, thumb wheel, and membrane. And basically that describes how they're physically constructed. In all cases, these switches are activated by a physical pressure, usually supplied by a human operator or a user or by some physical part of a system. Oftentimes referred to as man-machine interface, which is MMI, or human-machine interface, HMI. Again, how we control the system. So what are the functions of switches? Well, mechanical switches are used to switch either voltage or current, hence to deliver power to a load or turn something on or off. Other switch functions are to select one possible choice out of others, for instance, choosing a smartphone app. So here's a schematic diagram and a graphical picture of toggle switches. They're called toggle switches because there's a handle that you can toggle. So the first one, part A, shows a single pole, single throw. I can only make a contact between points C and A. Part B shows a single pole, double throw. So from C I can connect either to B or A. Part C shows a double pole, double throw, and here I have C1 and C2, and I can either connect C1 to either A1 and B1, which at the same time would connect C2 to A2 or B2. So they get switched in conjunction with one another. And again, the graphical description of that last toggle switch is shown in D. So here's another example, a picture of these. So what happens is on the left-hand side, we have a picture of the switch. Then we have its description. Notice there's one we haven't talked about yet, a 3P DT, which is a triple pole double throw. And again, there's three things connected at once to two other three connectors. And there's a 4P DP, a four-pole double throw switch. And then there's a graphical description on the right-hand side of how these things would be connected. There are numerous variations on the basic toggle switch. Terms used to describe their operation and connection arrangement are, again, things like single pole, double pole, multiple pole, single throw, double throw, three position, and so on. These switches may also be of the momentary contact type. Usually different AC and DC ratings exist for these types of switches. So here's again a pictorial of many, many different types of switches, and there's all kinds of different ones made by different manufacturers. More show and tell. Here's a slide switch as a toggle switch. It's a switch similar to the toggle switch, and these switches usually have lower voltage and power ratings than a toggle switch. So this switch here, you can see it's got screws to be able to be connected to, say, a chassis, and then it has several positions it can be slid into. Cat is here, so please disregard anything bouncing around and so forth. The cat loves to get involved with my videos. Push button switches. So push button switches are typically momentary contact type switches, but may also take on toggle switch characteristics. So here's a picture of a push button switch, and there's the cat's tail. Here we have in part B a normally open or NO switch. And again, there's a spring that keeps those contacts from being closed. Part C shows a normally closed or NC switch. And if you push the switch, it'll open it up. And part D is a combination normally closed and normally open switch. And here are a bunch of push button switches. Again, many, many different designs of these devices. There are things called limit switches. Limit switches are typically activated by the movement of some physical object so as to limit the amount of travel. So you can see on both of these switches, there's a lever, if you will, on top. And if I take and push up against that lever, there'll be a little bit of mechanical advantage that it'll take and cause the switch to either open or close. Micro switches, another type of limit switch, and micro switches are typically activated by the movement, again, of some physical object. The throw needed to activate the switch can be in the thousandths of an inch range. And again, notice that you get like a lever action here by this long piece of metal, which actually, if I move the end of it, I don't have to exert as much force, and it can cause the switch to open or close. Another common switch are dip switches, what we call dip switches. And dip stands for dual inline pin, by the way. They're switches packaged in the dip IC shape, and you can see that there are 14 pins on this switch, so there's 14 pins. Divide by 2 gives me 7 switches, and it turns out that switch diagram on the right hand side shows switch 1 through switch 7. So if I take and move those sliders, right now it turns out that, well, it's hard to say. Oh no, it says on and off on it. So pin 1 is connected to pin 14, pin 2 to 13, pins 3 and 4 are open, pin 5 is connected to pin 10, 6 is open, and pin 7 is connected to pin 8 on that switch on the left-hand side. Here's typical dip switches, pictures of real ones. The one on the far right is kind of interesting. That's a surface mount switch, and it turns out that normally you use a little thin screwdriver to turn this, and you can put it in the various positions, 0, 2, 4, 6, 8, and so forth. And so you have many different combinations that you can take and switch with that particular switch. What about rotary switches? They are losing popularity as solid-state multiplexers. Rotary switches can perform multiple complicated switching functions. These switches are constructed from one or more wafers with electrical contacts mounted on a shaft that can be turned. The switch may be wired to connect or disconnect numerous contacts. So here's some pictures of these rotary switches, and as you can see, there's many modules ganged together. The one on the far left looks like 1, 2, 3, 4, 5, 6, 7, 8, about 9. These switches are ganged together. And again, I turn the switch, and as I turn it, all those different modules turn in unison. Thumb wheel switches, you can see here it's set to 1776. Turns out that the switches go usually from 0 through 9, and there can be set to a certain setting. How about membrane switches? Today there's many different types of membrane switches that are used in a multitude of applications. These switches are very popular. There are two basic types, tactile and non-tactile. So what happens here is this one on the left, it's made up of various layers. And what happens is you touch it, what happens is you get a contact, and you have leads that come off that indicate this contact. Now, touch screens. Everyone's familiar with touch screens, new technology for switching. Touch screen technology has become extremely popular, driven by smartphones and computer displays, and basically it's a matter of software as well as some hardware that you can select many things by touching them. So we're going to switch gears now to electrical relays. These are basically the first current amplifiers. Relays were invented way back in the 1830s. Several different inventors are credited with building the first electrical relays. The first application was in telegraph systems to extend the reach of the system by relaying the dots and dashes. So the traditional electromagnetic relay works by the activation of an electromagnetic field. That's done by passing a current through a coil of wire to produce a magnetic field, which is also known as an electromagnet. The magnetic field in turn causes electrical contacts to either open or close to affect the flow of current through the contacts.